In scenario 11, we'll take a closer look at ArcSight's UEBA engine ArcSight Intelligence. ArcSight Intelligence employs unsupervised machine learning to establish unique and ever-evolving normal behavioral baselines for each entity it encounters. It then creates alerts for each instance of entity behavior that deviates significantly from the baselines. These alerts are called anomalies. The intelligence risk engine calculates a risk score for each anomaly observed. Anomaly risk is a function of the probability of that specific behavior occurring and the weighted average of the risks associated with the entity, the asset with which they interacted, and the method of interaction. Entity risk scores are then calculated by considering the entity's importance, which may be adjusted via tuning, and the aggregate behaviors observed for the entity over time. Consider an example in which Anne is observed to be active at 3 a.m. This is not by itself an indicator that anything is amiss, but it is unusual for Anne, who typically works between 8:30 a.m. and 6:30 p.m. on weekdays. Anne's risk score is therefore elevated to 15, which is still considered low risk. Anne then connects over a VPN from China, checks out an unusually large number of files from a code repository that neither she nor her peers typically access, and posts a significantly larger amount of data to a website that is unusual for her. None of these behaviors taken in isolation is necessarily a cause for concern. Rules that flag these individual behaviors would generate a large volume of false positives. But taken together, these behaviors are enough to elevate Anne's risk score here to 96, prompting security teams to investigate this potential instance of data exfiltration and any other activity in which Anne was involved. The ArcSight Intelligence user interface displays each entity's risks profile over time as a line on the matrix shown. Anomalies that contributed to the entity's risk are displayed as colored squares on the matrix, and a detailed list of anomalies is shown below the matrix. By zooming in on the matrix, you can see the set of anomalies that occurred within a specified period. The following anomaly shows that Alan's 95 attempted authentications in an hour exceeded not only the expected highest number for him, but also the average maximum for other people in his organization, which here is 2.5. Peer grouping can be performed manually, for example, to independently baseline the behaviors of a specific set of users, such as a red team. It can also be performed based on different account types, for example, to differentiate machine, service, or system accounts from human users. Automatic peer grouping is performed for certain anomaly types using k-means clustering.